for joining us today. As always, there's some free resources out there, or feel free to connect with us if you have any questions, concerns about our group, questions about Azure, anything like that. It's linked to our Meetup, our Slack page, our YouTube channel. All of our talks are recorded and posted there. If you need to reference them later, send them to somebody else. There's a slight change to the organization. Matt Braffhart is stepping down and replaced for Corey Gideon. Not to put Corey on the spot, hopefully by the next meeting we can have an introduction for the new year of introducing everybody who's on the cabinet and just doing a high-level overview. So expect that to come next year, since this will be our last presentation for the year. And our topic today will be Pulumi, presented by Basis Theory. Some free learning resources out there. And today we will be sponsoring the meeting. So we're going to give away 2 t-shirts, just as my head's in the cloud. And then I think on the arm it says Azure. You will have to be in the US for that. Other than that, we can either ship it directly to you or we can ship it to us, and then we can plan to meet up in Des Moines sometime to do that exchange. But we'll end up doing that. And with that, I will hand it off to Brandon.
Cool. I will screen share, make sure I get the right one. You should see my screen. Let me know if this is way too big. Or is it good size? Okay, cool.
I think it's pretty good.
All right, so cool. So we'll dive in. I'm gonna share my whole screen, so hopefully I don't get any embarrassing pop-ups from work, but we'll see what happens. It's always an adventure. So anyway, so Palumi, well, kind of what is it? So I think most people have probably heard of infrastructure as code by now. Probably most people are familiar with either things like Terraform or probably using something like CloudFormation or something like that, depending on your cloud provider of choice. So kind of talk through, I just want to kind of discuss kind of a few of the different options in that space and why Palumi sort of emerged from this area. So, over the years, at least personally throughout my career, I started off early on where it was a lot of like managing infrastructure directly in Azure, right, or Google Cloud or AWS directly, going directly into the portal, adding infrastructure, making changes, things like that. I think most of us kind of start off that way. I think some of us still kind of go in that direction when you need to like prototype something and verify something works and be able to get the, to view exactly what the state looks like for how your app desire to work, and over time that works okay to start. But in time, especially if you start dealing with things like compliance, right? If you're dealing with like PCI or SOC 2 or HIPAA or other types of data regulatory compliance, now all of a sudden you become that you have to answer to an auditor, and they're going to want to know like who had access to what when, what was the state of the infrastructure, how are you handling like encryption key management, sensitive data and secrets and things like that. So you start running into some of those things. The other problems you start running into is like dealing with like shared infrastructure. You've got like the platform or infrastructure team who needs to go provision shared infrastructure, and you did make certain settings and secrets available to other teams of engineers. Maybe you want to build things that enable developers to go provision their own infrastructure. Maybe you've got like a web app or something like that you want to enable them to stand up. And you typically don't want to start building a system where all of a sudden you're granting everybody access to your cloud environment. So then you start looking at different approaches. So, one common approach that was pretty early on is just using things like CLI tools, right? Azure has a CLI, Google Cloud has a CLI. You could use something like AWS's like Boto 3. And that works fairly well if you're just trying to do some really basic things. And then, but what most teams end up arriving at is something like, CloudFormation, right, which is specific to AWS, ARM templates, so Azure Resource Manager, and using some of their, I think it's like JSON structured templates, something like that, which again works okay. But, when you're dealing with some of those, it's really hard to deal with like refactoring. You have a really hard time sitting there and like knowing like dependencies. So for instance, let's say you declare a variable, let's say on a SQL instance, and you want to refer to that server variable name into like your app service, maybe as an app setting or something like that. Like, how do you reference that? And like, that's not really conducive when you're dealing with like YAML and JSON and things like that. So essentially what ended up emerging is all of a sudden now all these cloud providers started developing their own tools, right? Like AWS has CDK, Cloud Development Kit, which you can write in, I think like C# and Java and a few other programming languages to be able to code against in replacement of CloudFormation. Azure is developing Bicep, and then that works pretty well if you're like single cloud, single provider type options, but it doesn't really work well when you get into like multi-cloud, multi-provider options. So then, in comes Terraform, and Terraform tried to solve this problem. They essentially have like a language they call HCL. I think it's like at HashiCorp something language, and then under the hood, essentially it's executing Go. And so then it's using Go under the hood to essentially like set and update state specific to your stack. And the nice thing with Terraform is that all of a sudden now you could have your application be using Azure. You can provision your Azure. You could also go provision not CloudFormation, but like Cloudflare. You could go provision Okta. You could provision all these other services, and you have one kind of language, one kind of structure to kind of rule them all. But I personally, over the years, like I prefer more of like, like a DSL, something that's like more in line with what the developers are already writing their code in, right? So most developers are probably using something like C# or Python or Go or TypeScript or something like that, and having to all of a sudden context switch to move over to Terraform, all of a sudden now requires me to switch my brain to be thinking about C# consistently to now all of a sudden I'm having to deal and look at HCL and wrap my head around that. The other thing that HCL with Terraform that I think does pretty well is that it allows really like kind of breaking your infrastructure up. So like you can really nicely reference other modules and other resources across different things. So like, for instance, I could really easily have like a folder that has all of my database configurations in it. I could have another one that has my app services in it, and I can reference that usually by some sort of naming convention to be able to go pull variables and other values off of other resources. So they have some of that flexibility built in, which is really nice. But one thing that, again, like going back is like, I personally we started looking at this at where I work is we started looking at alternatives, and that's kind of where Pulumi was brought up as a suggestion. So we kind of went down this path to try it out. And one thing I really like about Palumi is it basically uses the languages I already know, right? So we actually are a .NET shop. We're hosted on Azure. We also have some stuff that's written in React with Next.js on the front end. And what's nice is like on a per team, on a per project basis is like we can have all of our Node applications written in React and Next.js. We can provision all of our infrastructure using TypeScript, and then all of our .NET like APIs and other services, we can provision all of our infrastructure using C#. And I don't have to sit there and like, as I'm working in a project, have to sit there and context switch as I'm moving between my infrastructure, my application code, and like all my tests. I'm all consistently working in one language as well. Another really nice thing is that along with that, you still get access to all of the things that you would expect with Terraform. So they have basically providers for all three major cloud providers, as well as some support for Kubernetes in here, with extensive documentation for all of these. I will call out one specific nuance on these two, and we'll discuss that up here. They also have some kind of esoteric cloud providers out there, ones that aren't quite as popular as well. They have some support for that. And then like at where I work, we also use Auth0 for identity management. We have Azure AD support, so we do some application management against Azure specific resources. We also are using PagerDuty for our on-call, so we pulled in the PagerDuty provider as well. We also are using Datadog, so we use that for synthetic testing, and we also have some specific logs and monitoring that we ship out to Datadog. And we also have Cloudflare that we're using for our DNS. And the other nice benefit is now, as an engineering shop, we have one tool to govern and rule all of this. We enable developers to use the language of their choice. And now I'm not having to go between, well, I'm working in Azure, so I need to go use Bicep or ARM templates. Oh, now I'm all of a sudden over in Datadog and I have to build my own thing to go interact against their API. Like we just use one tool across the board and we can manage all of this. We also use GitHub as well. There are very similar to Terraform. There are a few specific utility libraries. So like random, this was pulled directly from like Terraform as well. And basically you can use this. One thing I wanted to call out in here. So for most of Pulumi's packages in here, most of these providers, they essentially are just wrappers for Terraform. If you notice on here, this package is based upon the random Terraform provider. And you can legit like click into that and you can see exactly what they're pulling from. And if you go look at the docs for all of this stuff, they like, there is no shame. They pretty much copy and paste all the docs over, all the descriptions, all the naming, everything is one for one. And to just kind of show that in action is, for instance, here is Terraform's basically registering an app service in here. Notice it's like name, location, resource group name, app service plan ID, right site config, app settings, etc. over here. And if I was to go look at Pulumi's equivalent, right, location, resource group name, app service plan, site, right, it's one for one with Terraform. So if you're already using Terraform today and you're like, okay, cool, like I'm already a Terraform shop, I think this is kind of interesting. It should feel a little bit at home there. They actually also have a Terraform to Pulumi migration. So they actually have a tool out here that will take your existing Terraform and convert it over into Pulumi, into the code programming language of your choice. So you also have the ability to, like, if you're already on one, you can kind of mix and match or slowly migrate your stuff over as well. And then they show kind of what that looks like in different languages as well. So there was one gotcha on here, and I just wanted to call this out. So originally when Palumi got started, again, they started off with pretty much like a rip it off from Terraform, right? So if we go down here and we look at the classic provider for Microsoft Azure, and they'll call this out like this is pulled from the Terraform provider. However, the direction they're going, and this is actually one thing where I give them a huge leg up over the other tools in this space, like Terraform and other comparable tools, is they're actually in the process of building native providers for all of these. So on this one, for instance, like their new one, this Azure native that they have, they started releasing this, I think about 7 months ago, I think was when the first release came out. But on this one here, notice they're not pulling from that. And I'll just show this real quick on their Azure native. So the same web app that we showed, the app service up here, this is actually, if you go look at here, and we'll look at a few of these, this is actually using the same thing that you have in the Azure REST API. So if you're, for instance, if you're today provisioning infrastructure using Azure, under the hood, typically with like the ARM templates and the Bicep, most of that's really being driven by Azure has an ARM REST API that they have, their own resource management solution. So on here, when they actually call create or update, they're actually hitting this management.azure.com specific to your subscription, specific to your resource group provider, and then actually the name of it, and you're passing in all these parameters. So when you start looking at these things, now you get into things like client cert mode, cloning info, hostname SSL state. Well, if I come back over here, right, you start seeing cloning info, client cert mode, etc., right? The naming matches up with that. And one thing I really like about this and why we've, at where I work, why we started moving over to this Azure native provider is now it makes debugging and setting up your cloud provider way easier. So like, you're not also, the other benefit of this is like, we also mix and match all of this. So we actually, one nuance is like, we're not really a fan with how the Azure ARM REST API works for Key Vault, for instance, because they only take what's available in the control plane that comes from the Azure ARM API. But what the Terraform provider gives us is also the ability to manage our Key Vault instance through the control plane as well. So we get kind of the best of both worlds with the Terraform one. We can mix and match all of that with our with Pulumi. You're not restricted to just, oh, I can only choose providers that work with the Terraform stuff or with the native stuff. Like you can still mix and match it like you would with if you were using Terraform. So we have that benefit as well. So that's kind of like a one nice thing, and that's like one big gotcha on here, especially if you're getting started. Like I recommend coming and looking at using the Azure native, and then also with their, I'll just go back to here real quick. Actually, I'll go back over here. And if you go look here, the one thing to keep in mind, if you are, for instance, like a Google Cloud or an AWS shop, they are in the process as well as building native providers for AWS and Google Cloud. They're just not, they're still in preview mode. So they don't have a v 1.0 release. They're still building those out. But just keep in mind, if you're looking to adopt this and you're not an Azure shop, or maybe you're a multi-cloud shop, just keep in mind that you probably want to start with the native ones, not start with the classic providers they have. Any questions on any of that before I dive into the next chunk? All right, so let's start seeing some of this in action. So I wanted to call one thing out when we're looking at this. So Azure has a couple concepts that are probably worth discussing. So one thing that is worth calling out, and I will come back over here and let's take a look specifically. What I'm looking for is stack, things like that. All right, so architecture and concepts. Let's discuss some of this. So they have essentially, there's two different things. So there's stacks and there's state. Are two key concepts that you're going to need to learn as you're working specifically with Pulumi. So a stack is essentially what they're kind of describing here, right? So it's essentially kind of the combination of, here are the resources I know about, here is the configuration I use to go configure that, and then some sort of stack name. And typically those stacks are tied to a project. So you might have a stack that's called, like in the example I'll show, it's like library app / dev, library app / prod, right? And so you might have two different stacks there. And then within those stacks is you have state. And so if you're familiar with Terraform, Terraform has the concept of a state file that gets generated. And the state file basically is like, what is the state of my application with all the configuration tied to it? And that state file ultimately is what Pulumi, it's a SaaS product, so they will actually manage that state file for you. You do have the ability to opt to go manage that yourself. So you could say, I actually want to host this myself. Like, let's say you want to push up to like Azure blob storage and you want to manage that yourself and handle all that. Like, that's available as well. I typically lean into just using SaaS products, like for the $1,000 a year or whatever. It's usually worth I think they have a free tier with Palumi, but like for like a decent sized company, like $1,000 a year for having somebody else manage your state file is well worth it. So those are kind of two really important key concepts. We'll show a few things around that here in a bit, but I just wanted to bring those up. And I'll show some of this in the portal as we're working through this, so you can kind of see how all this stuff kind of connects together. So next thing we'll look at, so let's just jump directly into the code. So in this application I have here, by the way, all of this code is available on github.com/Weber. And then I've got this library example application out here. So if you yourself want to pull any of this code down, 100% of it is open source. It has the Pulumi stuff in here, full setup instructions in here, how to run all of it, how to get it all working. Everything is Dockerized in here, so you should be able to pull it down working. I've also made this be multi-platform. So for instance, I'm running M1 Mac, so I made sure it works on Silicon architecture as well as the other. So it's all available free and open source. So feel free to pull it down and play with it if you want to, or if you just want to follow along, that's cool as well. So so in here, basically, when you create a new application, they do have a Pulumi init command. So I could come out here, for instance, and I could do, I think there's like a Pulumi init that I can go create on here. I think it's like Pulumi, and then they actually have an init command where I can actually create a new project. And then what's nice about this is I actually have the ability to, or it's Pulumi new, and you can actually create a new project, and it will actually scaffold some of this stuff out for you. And will basically, what it'll prompt you for is like, what language do you want to run in? It'll ask you the name of your project, and then it'll ask you for your first stack name, and it will create all these files for you that you need. And then basically from there, then you're mostly just copying and pasting code directly from their docs and filling it in. So essentially the first thing that you're going to see get created is, like, if you're doing a .NET project, is you're going to see basically like it's just a console application. So if I were to come in here and right click and choose properties, and we look at that. It's just a console application that's being executed. It's not like a class library or anything else. So basically what they're doing under the hood is when you're running this and saying Pulumi up and actually apply the changes, they're actually running this console application, applying the configuration and starting the application for you. And then it's basically under the hood. This is actually generating a state file and some outputs, and it's pushing that up to Pulumi as it's provisioning your infrastructure. So the other file that you're going to see get created when I create a thing is it's going to create this Pulumi.yaml. And so inside of here, you still have the concept of configuration. And there's a few different ways you can set configuration. So you could have configuration set in here, and that configuration is global to every stack across that project. So in here, I've got a project name library API. This doesn't know anything about stacks at all. It's setting the runtime as .NET. Purely, you can see that because I'm running C# here. And then the description is like, I just had it'll prompt you when you create the project, like, what do you want a description for this? And like that description just shows up in the portal. There's nothing super fancy there. We also end up with, when I created that, I also get the option to create a stack. So in this one, I said, I'm going to do environment specific stacks, like a dev QA prod is typically what you would do in here. So I can do a pulumi.dev.yaml. And so this file gets created because I named the stack dev. And in here, if you notice that config is set up, and these are environment specific configs. So on here, you also need to realize that the first part before the colon, so notice library API, this is exclusive to my project. But in this Azure native, that is exclusive to the Azure native provider that we saw back over here, right? So under this Azure native, that prefix is exclusive to here. And so you end up basically configuring either the provider that you're interacting with, or you provide configuration options for your application as well. So those are kind of a couple options that you have for there. The other option you can do when you want to configure is you can also use a CLI. So not integration, where's my infrastructure one? Setup infra. Okay, so I've got another one in here. So essentially what I end up doing is I can also set configuration as well here. So I actually can use the Pulumi configuration, the CLI, and I can say Pulumi config set, and I can actually set these Docker settings that I want to be able to configure my application with, and I configure that way. You also have the option to set secrets as well. So when you do -- secret, it's actually setting a secret. And what Pulumi is doing under the hood is they're actually encrypting that value. And then at the time of actually applying the changes, they do just-in-time decryption. But what's nice about this is when all these things are pulled from, like, if you're using like GitHub Actions, all these secrets end up getting redacted through your logs, so you don't see secrets being logged out anywhere. So you don't run into that security issue. When you actually need to use those secrets, though, or that configuration, you have basically a configuration up here. So when you create your configuration, this registers that config with Pulumi. And then from off of here, you have a variety of options. So you can do things like get, right? And so there's a variety of get operations on here, right? So I can like get Boolean, get int, get, right? And you can do some get object and do some casting. One thing to note with get, which is different than require, is get will not error out in the event that doesn't return a value. It can be completely optional. And the nice thing with get could be something where you could do something like I could do the app service plan tier here, and then I can do something where like, oh, if I don't find anything, default to, some tier, right? Like it could be default to standard or something, right? Like you could choose to say, always have a default, but then provide the option to override it. So that way you could say like my default across all stacks or across my environment or whatever is this, but in the event that you don't find one, if I didn't declare it default to just something else. The other option you have in here is require, and require is exactly what you think it would be. Basically, it says require that the configuration is set. If it's not set, throw an exception. So then basically it'll error when the application actually tries and starts. There's one additional thing in here, so I'll do require secret. With this, remember that back over here when I did the setup infra and I actually did -- secret in here. What I'm actually referencing is I do require secret, and it allows me to read that secret value in. So that's how I'm able to go ahead and set and an app setting to be able to go set my Docker registry server password, so that way I have that available so I can go pull my Docker image when I run this app at startup. Any questions on configuration? All right. So now that we've talked about configuration, the next thing you typically are going to want to understand is there's a few other things available to you as well in here. So there's a couple things in here that are very, very specific to Azure on here. So this client configuration in here, this get client config is very specific to Azure. So if you're working with Azure, you're typically operating in the context of a couple things. One, you're operating in the context of a tenant ID. So if you're familiar with like Azure AD, for instance, and I'll just jump right over here. Let's go over to, let's go back over here. Let's do Azure AD. Where's Azure Active Directory? Yep, here we go. All right, so inside of Azure, you're typically operating in the context of a tenant ID. Notice that 4D59 piece that comes back, that's specific to my tenant that's running within Azure. Every time you create a new tenant out in Azure AD, you're going to end up with a different tenant ID here. And so the interesting thing with this is like, you know, a lot of organizations that I've seen personally when they use Azure is they typically have like one Azure AD tenant, one Azure AD subscription or setup, and then they have multiple subscriptions within Azure, one per environment. So like you might have like a dev, a QA, and a prod subscription where all your resources ultimately are getting put into. So over here, when I go set that up, it's pulling back that tenant ID to be able to go know specifically like that's the Azure Active Directory instance I need to go talk to. The other thing you're also going to be concerned about is that object ID. So in application registrations, is this actually in the setup configuration down here to actually set it up, is I have this infra creator thing I created. And so on all my applications, this infra creator right here, which I have this identifier right here, this object ID, that's what's pulling back this object ID. So that's like the current user principal that the Pulumi is running under. And the reason why you need that is you might be doing things like, you know, like providing data plane access to a resource for Pulumi to be able to go provision stuff, or you know, maybe you need to configure your application a certain way or something. So that's basically why you would want something like this. And then very similar to how you would go set up Azure, right? So in here, you're going to have a class called resource group. So this is actually part of Azure is directly. So I'm going to pull this back. Like this is actually being decompiled directly from the Azure native resource. So there's nothing special I'm doing there. I'm just using that. And then obviously, as you're creating resources, you're tying it all back to that resource group, right? So I'm actually tying it back. There are a couple things I want to call out on here. So typically one thing, at least when I'm setting up Palumi apps, is one gotcha that you run into with any form of like procedural set form of like infrastructure as code. And this is actually where Terraform shines versus Palumi. Is Terraform, I could have all this stuff be broke out into like all these different folders, and things just instinctively get linked up based upon how I reference and name things. So Terraform is building this big dependency graph of all your resources, but that doesn't work as well when you're dealing with Pulumi, because like Pulumi is like when you're writing it like code, you're very much like do X, then Y, then Z, right? So you have to set this up. So that can get really, really cluttered pretty fast when all of a sudden, let's say, you know, you've got, let's say, your main infrastructure project, and this is the thing that's building, let's say, your Azure front door instance and your WAF, and you know, you've got, let's say, app gateway, and you've got, you know, your VNet and NSGs, and you start adding all that stuff in. Next thing you know, this file could be like 3,000 lines of code. Well, that doesn't become a very maintainable solution. So you have a couple options at play here that you can work with. So the first option you have is, one option is you can basically start building out custom modules. And this is typically the approach I take when that resource is constrained specifically to a single stack. So in this situation, I actually have a component resource. This is something specific to Pulumi. This is not tied to a specific resource. This is actually in their docs. And what you can do is you can basically create modules. And in these modules, you have a set of inputs and outputs. So the first thing that they're going to take in is an argument, right? So you can define your own argument class. So this argument is I'm just inheriting from resource args, and then I have a series of inputs that I'm defining, right? So on this one, I'm like, hey, I'm going to create an application insights instance. I want to define a type. I want to tie it back to log analytics workspace, and I want to tie it back to my resource group to associate that with a specific resource group. And on here, what I'm doing in this is I'm actually creating that instance, and I'm fully defining all of those configuration values in here. The other thing that you have is then on your resource, on these component resources, you can create outputs. And outputs are things that then you can reference from other things. So in here, notice I'm exporting, add the output of instrumentation key. So when I come back over here and I create these application insights, then what I'm doing further down in here is I'm actually referencing the instrumentation key when I'm setting my app settings on my web app. So I can reference those values back out. So that allows you to kind of clean this up a bit. So now all of a sudden when I'm building in, let's say, a SQL database, right, which gets a little bit more complex, all of a sudden now in here I create, a random username, I create a random admin password, I'm creating the server, I'm creating the database, I'm creating firewall rule, I'm creating diagnostic settings, extended, audit policies, all of that type of stuff. Notice I'm doing all of this work in a single module versus having to pollute that main startup class that we had back over here. So it kind of allows you to sort of modularize your infrastructure a bit. And then you can also, if you want, and we actually do this as well, is when we have shared resources across multiple projects, we break all of these component modules out into a separate modules project. Like we have a NuGet package that we bundle these all up and ship with it. And then all I'm doing is I'm pulling in my NuGet package and I'm just building this. So I don't even have to have all these pieces of code in here either. So that's kind of an option that you could do to like kind of make those reusable. As you could build modules or these resources and then share that across your different projects as well. So it kind of allows you to have a lot of reusability there. The other thing that's available as well is stack references. So stack references, if you're familiar, if anybody's familiar with like how Terraform works, is on a project, for instance, I could have this API stack, I could have an output here, right? And so I can output of, I don't know, blah or something on here, and then we'll just grab something like this. So we'll just do something like this. So I can have an output on my overall stack. Very similar to how you have an output on that individual module. I could have it on the overall stack as well. And the nice thing with the stack doing outputs here is now all of a sudden I can reference that stack from another stack, and then I can grab this output as an input into my other stack. So Pulumi has the concept. I can do the quick search, Pulumi stack reference. So they actually talk about stacks and stack references. And what you can do is you can create a stack reference in here, and that stack reference allows you to reference a specific project with a specific stack name. And then you can say call get output to pull a specific output by name out and then get that value. And then you can have like casting on here as well to be able to get those values out. And so what's nice about this, and if you notice, like give you some examples here specifically, like what does it look like for prod testing staging, right? We actually use this in our application. A good use case might be we have PagerDuty set up, right? And so we have specific on-call things. So as a team, like all of our resources are tied to specific teams. So we know we want to use the PagerDuty output config to know when an error is thrown in our application, where do we need to route that alert to? So that way the person on call with the appropriate team ultimately gets notified when an application starts erroring. So we use the stack reference output from the PagerDuty stack as an input into our application stacks. So that way we can configure application alerts to fire to the right team. Any questions on any of that? All right, so we'll dive into one more really important gotcha. So I've talked about inputs and outputs, and this is, if you're new to Pulumi, right, this is probably the single hardest thing to wrap your head around is inputs and outputs. So on here, this one here, we have the concept of an output here, right? And I have the concept of an input here. And think of inputs and outputs as they're like lazy loaded values, right? So if you're thinking like programming language, it might be something like a task or a promise or like a lazy, right? If you're familiar with like C#, right? You can use things like the lazy keyword, right? On things, think of it as like that. So the value doesn't actually exist yet. And one thing I typically see a lot of people run into a lot is what they end up doing is something like this. I see this all the time. Is I want to interpolate a value and I want to do something with this. This will still work, right? It doesn't error on you, right? Because ultimately what's happening is when I do this, is C# is taking over and it's trying its best to take whatever the string reference of this value is and try and get basically call to string on that, right? So when I see a lot of times I see like string concatenation or string interpolation and things like that, I would say probably once every couple of weeks, one of the developers on our team is like, I'm getting some weird output and it's not working, right? And usually this is the cause. And so what you end up having to do instead is if you want to make that work, you actually have to do something like output.format on this. And when I do that, this function gets called, and what it'll do is it'll wait for this to actually evaluate to a real value, right? So when it becomes not lazy, actually when that resource is created and that value exists, it will actually get the real value and insert it in. If you do it like this, then essentially what you're going to end up with is you're going to end up with something that's like the C# equivalent of like output bracket system.string, right? You're going to get that thing that typically most of us see when we're dealing with like IEnumerables or lists and things like that, where it doesn't look like the value, it looks like some sort of index to a value, right? So you're going to get the same problem there. The other thing that you also need to keep in mind when you're, if in the event you need to act on the underlying value for this, is you can't just like do something and do like, equals, blah, right? Because this isn't real, right? This is not, you're ultimately trying to compare an output or an input to a type string. So what you have to do instead is you have to do apply. So there's an apply operator, and this is another extension method that Pulumi provides. This actually will wait for this value to get rendered when the dependent resource is created. And now when you have this, now you can do something like ID equals blah, right? And then this will ultimately render into a bool, right? So it's actually going to tell you, like, I don't know how to convert from a bool to an input string, right? That's basically what the error here is saying, right? Because we're just basically doing that. So it's essentially what's going on here. This is still valid, right? That the reason why this works is we're doing apply, which ultimately creates a value and then sets it back to this. But you don't have to do that when you're just doing inputs and outputs. They're kind of synonymous within Pulumi. This is probably the hardest concept to wrap your head around when you're dealing with it. But you just have to realize, like, when you deal with an input and output, make sure you're always using apply. Make sure you're using one of their like output format, or they have a whole bunch of options in here like all. So all basically means like take a list of inputs and then apply the values for all of them to get a list of outputs and then a list of like their values. You can do things. You can do things like tuple, right? So you can actually generate a list that you can do things with. Note there's a limit on here. I think you can only do up to 8 values before you hit the tuple limit. And then there's some other things in here like some unsecret, create secret. Is like there's a few other values in here as well that are available to you as well. Any questions on that? All right, so let's get into a couple other more advanced use cases in here. So in some situations, you may run into, there's something that I really want to call out in here. So notice in here, I'm calling protect true. So on all of your resources, when you create a resource, you typically have 3 things available to you when you create a resource. You have the name of the resource that you set. You have the arguments for that resource that you can set. And then this is all the arguments that are defined. And then you have these custom resource options. These are going to be very, very synonymous to, if you've worked with Terraform, like a lot of this stuff will look very familiar. So protects exactly what you think it is. So one of the problems that a lot of people run into when you're dealing with like some infrastructure as code, eventually you'll run into it, is you end up in a situation where something's going to force a delete and recreate of a resource. And it's not really a big deal when you're dealing with, let's say, like a web app in Azure, right? Because typically it'll get deleted and recreated with the latest settings, and it's like, okay, well, whatever, like the app will come back. But it's a really big deal when you're dealing with like a database, right? Or a Key Vault instance, right? Or any other KMS solution. So you can do something like protect. And what protect ultimately does is basically says, in the event that it detects a deletion, it will fail applying those changes. So it does not allow you to delete the resource. It will force you to programmatically go through the Pulumi CLI and unprotect that resource. And you have to do that as like an administrator. So somebody with administrative access over your thing, usually like an infrastructure person, would have to come along and actually do that change for you. Some other options you have in here. So we have protect, but we also have things like depends upon. So depends upon basically is what you'd expect. So you can actually come in here and I could say, well, if for whatever reason, if I didn't have an implicit dependency because I was using this value, let's say I named this just name, right? If I didn't provide this, like let's say I just did that, right? Well, these two resources, because there's not an implicit dependency, these two will try and get created in parallel. And you may run into a situation where that happens and you're like, well, this will actually fail because it'll be like, I don't see a server with that name. So it's going to blow up. So the way you can get around that is you can do a depends upon. So I can actually say depends upon this SQL Server instance. And what we'll end up doing is it will wait for this resource to get created before it creates this resource. So I'll put this back to look exactly how I want it to look. And yeah, and there's several other options in here. So if you dig into any of these, those are the two that you're probably going to want to grab. But like delete before replace, sometimes there's situations like that, things like that. And then there's import IDs, which I'll talk about imports in a second. There's one other nuance to here. So let's go take a look at something real quick. Key vaults are a really good example. So, and I'll show what this looks like inside the portal. So by default, Palumi will take the name of your resource, the name that you provide here, and it will append 7 random characters on the end of that name. And the reason why they're doing that is they basically are trying to make it so that way you don't end up with naming conflicts, because a lot of times, like with Azure and Google Cloud and AWS, they all have this problem where like things can be like, they have to be globally unique across all tenants across all of Azure. So for instance, primarily like a website, right? Like, so in this situation, I think I called it like library app. So the URL is something like, I think it's like library app, Azure websites, right? So it's actually hitting like, this is the name of my app. Well, like if for instance, if somebody else came along and claimed that name, I couldn't use that name because I wouldn't get a unique DNS reference to that. So that's the default behaviors. They would then append 7 random characters. So then my website URL would be like library-app, and then there'd be 7 random alphanumeric characters added on to the end. So the way you can get around that is you can use something like name, right? So I could come in here and do this. And what would end up happening is it would create a Key Vault instance out there with stupid pop-ups. It would create it with that name explicit. And not everyone would agree with me. I actually kind of prefer being very explicit on my names. It allows me to find things. With randomization, it's okay, but I end up putting a lot of dependencies on output parameters, and then to be able to do things like run integration tests or set up alerts and things like that, right? Because like if the name changes all of a sudden, maybe I have some custom query that's searching like log analytics for a specific thing, and now I'm having to do starts with versus exact matches or something like that. But in some situations, you actually want that to be randomized. So it's like Key Vault's a good example, like because Key Vault's purge protection built in some situations, you actually want to assure that, because if you ever need to like recreate your stack, let's say in a dev environment or a sandbox or something, like the purge protection will like bite you right away. So we always just leave that on, and you can see that in action. So if I come back over here and I do all resources, notice all my stuff normally is like library app insights, but then Key Vault, notice there's like that 7 random characters or whatever it is. I guess it's 8. It's just the random characters on the end. So that's something to keep in mind, like however you want to approach it, that's entirely preferential, what you want to do. And it might be resource by resource basis, but really when you define your modules, you probably are going to define that behavior inside maybe a custom resource module. One thing to keep in mind too, though, that also will bite you is like an example of Key Vault is Azure actually has resource name limits. So I think I can probably find that real quick, like Azure resource name limits. And I'll say this, we've been bitten by this a lot. So if you look at like APIM, right, like the name of everything, like how long you can have it in here. So I think there's like Key Vault. Key Vault has a limit of 24 characters. So in the event that, let's say you're allowing Pulumi to append 8 characters on, you just lost 1/3 of your naming limit that you would normally have. And all of a sudden now you have to reconcile that where you have to be very careful with how you name things so you don't end up in a situation where you exceed that 24 character limit. And I only see it on a handful of resources. I have no idea why there's these arbitrary name limits, but these things have bitten us multiple times as well on some of this stuff. Maybe Derek can add insights at the end of why that is. So that's one additional thing to just keep in mind as you're working on this stuff. So cool. So you've built your stack, you've got all this stuff defined as code. Now you run in the situation of like, now I actually need to go actually deploy this stuff. So we'll just run through a real quick example of showing what all this stuff looks like, just so you can see it in action. So one thing to keep in mind, when you do their quick start guides for everything, they're actually going to tell you like you have to configure your application. Like since we're using Azure, we actually have to configure like our client ID secrets, all of this stuff, actually setting all that up is directly in here. You'll see all this right here. So in here, I actually describe like what I'm doing and why, but I'm basically plucking values out of this JSON when I did this. So that's basically what this Python 3 is just basically doing parse JSON in there. But one thing that Pulumi, so what we're doing when we run our CI/CD is I'm actually using Pulumi's CLI. And what I'm specifically doing in here is I'm actually defining saying, if I'm doing like a pull request, I actually want to run it in preview. And preview will actually show me what that is. And I believe there's one additional thing. I think it's like Diff. I think it's like Pulumi preview Diff. Preview Diff. I'm pretty confident that we can get the output there. Yeah, so Diff. Let's just grab this real quick. So I think this could be pretty cool to show. So I'm going to throw Diff in there. And Diff, what this will actually show me is instead of just preview showing like these are the resources that change, Diff will actually show me what changed about each resource. Like it'll say like you're changing from value 1 to 2 type thing. And then when I call Pulumi up, what Pulumi up is doing is it's ultimately actually applying the change. So you're actually saying like now actually apply. So I actually only want to run this one on PR, and then I do up when I deploy. And I can actually do that through, because I'm using GitHub Actions out here. So in here, if you notice, I'm doing is preview or is PR workflow on my pull request one. So when I'm running that, I'm doing that. And then when I'm actually doing on verify down here, I'm actually not applying that. So the default will fall back to applying it and it'll actually update the changes out there. So I'm going to just go ahead and do that. Let's just make a quick change. So I'm just going to go in here. Let's change this from capacity 1 to 2, right? I just want to make a real quick change, and let's do that real quick. This should be pretty simple. So let's go in here. Let's do a get checkout -b, and we're just going to do bump capacity. Let's create a new PR. So I'm going to do that. Let's do an add, do commit, and then we're just going to do a bump capacity. And I'm going to push this up. So I'm going to push this up to my repo real quick. We're going to come out here. It's going to detect a pull request, and it's ultimately going to notice my change here and then the diff here. I actually want to go see what that looks like on the output. So it's going to run some checks. And so this is using GitHub Actions under the hood. Nothing too crazy. So when I view this, the way that this PR is set up, where I'm going to run a whole bunch of these things in parallel. So it's going to build my Docker image. It's going to build my app. When both of those things are built, it's going to run my acceptance test as well as scan my containers. I have some security scanning, and none of this is Pulumi specific. This is just the PR thing. But this verify infra is the piece that we ultimately care about here. So this will actually run. It's setting up all this stuff. It's setting up everything. So we'll see this here in a second. So it's doing a verify infrastructure. And so this is actually running against Pulumi. So it's logging into Pulumi using my access token, specifically into my stack. You'll be able to view it in the portal. I'll show this at the end, specifically what gets put into the portal from like a state file and everything. Just got to download the Pulumi provider. There's a little bit of an overhead here that has to do. So, okay, so cool. That's exactly what we wanted to see, right? So if you look in here, the diff, what it's actually showing you is notice that minimum instance count increased from 1 to 2, as well as my auto scale settings, right? So I have an auto scale setting in here and I bumped it from 1 to 2. So I'm actually increasing the count, right? So this will actually, if I were to merge this, it would actually increase the size of my apps, my auto scale within Azure, which I think is set up under my app service plan. I have some auto scale rules in here that I've defined, and my default instance count is 1. So what essentially it would do is it would bump that from 1 to 2. So then basically now it would force that scale up to 2 instances if I were to deploy that. The other really nice thing too is within here, I think I've got some integrations. Palumi actually has a configuration you can add, and it creates a Palumi bot integration. And you can configure it. You can add this from the marketplace. They have it in their docs. But the other really nice thing is on here, notice as well is it adds a comment. That Palumi bot actually adds a comment to my pull request, showing me exactly what changed. So if you're doing like a pull request and you're doing a code review against somebody's code and they're managing the infrastructure, not only can you see it through the actions through your whatever CI/CD tool of choice, but through GitHub with that integration, I can also see specifically what changed. So if all of a sudden, like, wait, I didn't expect any infrastructure changes, I now can see this and I know to go investigate why that is. So that's just kind of another nice, really nice resource they have available to you as well. So let's go out to Palumi. Let's log in real quick because I want to show what this looks like. So I'm just going to sign in. Okay, so this is in my own project in here. So in here, essentially what we end up doing, right, because we've named here, right, we named this library API, and then this stack is dev. I should see basically my library API project, and then I've got that one stack in here of dev that we see right here. And so if I click on that, you're going to get a whole bunch of things that are going to become available. Remember all those configuration values that we set up before, along with our secrets? They all become available as part of this stack. Anything that's defined as a secret will get removed. Notice it's saying it's actually encrypted. So any secrets actually get encrypted. You can't get access to them. So they're basically locked away. But notice like all that capacity and everything is set up in here. We also have some tags that are defined on that thing. Some of these are driven by Palumi itself. Some of them are defined by me based upon like the Git repo. You can get full audit history. So if you want to go back in time, right? So if you notice like some of these, I've got some failed builds and things like that from like upgrading to .NET 6. If you want to go look specifically and see exactly like how it was triggered, specifically what the PR was, specifically what the code commit was, you get all this information directly through the audit. Like this is really nice to go. We actually, when we do our audits, we actually show this to an auditor. So they have full availability of like what ran when against what environment. Like you have all this available through like an audit as well. The other nice thing too is you have with resources. So this is all the resources that got created, like everything that got created. There's a graph view. This isn't really useful in this scenario. It does when you have like weird interdependent stuff in there, but the list is pretty nice to be able to see. And then also you get to see what's protected and what's not protected. And then just some general settings. So they actually talk about like, what do you need to do? Like you can destroy resources, remove the stack, etc. Some of those things are available as well. So you can do some things like that as well in here. And then the last thing I also want to show, I know we talked about this. There's actually, it's like Palumi stack export. And I just wanted to show this real quick because I think this is useful to see. So on here, I'm going to show this real quick. So I'm going to do I'm going to actually go into, and let's do a Palumi stack ls just to make sure I'm selecting it. Okay, I've got that. And let's do a Palumi stack export -f file, and then we'll do output.json. Yep, we'll select that. Okay, cool. So now I've got this file output.json. So earlier on in the talk, I mentioned there's the concept of like stacks and state files. And then ultimately what this is doing is we're exporting the state file with all that information in the stack. And in some situations, now this is a very edge case, but there are some times when upgrading a module fails, right? Going from, let's say, version like 1 to 2, a major change. We actually just ran into this, like the Azure AD provider. It's a bug within Terraform, but because of the way Microsoft changed the application provisioning, it actually broke when we upgraded to the latest major version. And the only way we could fix it is we actually had to go in and edit our stack. So you can do a stack export, edit the stack, and then do a stack import to re-import that back into upgrade to the latest. And so if I do a code on output.json, now when I go look at this, you can see all the resources that I have in here, and you can see exactly what everything in here was created as. So everything in here gets defined. This should look very, very similar to what you'd see like in a ARM template, like very common inputs and outputs with everything. So you can start kind of seeing this and you can play around with this. You can also, if you need to, if you, for instance, came in here, for instance, if I came back over here, let's go look at library. Nice thing within Azure, and let's go to a later version of the thing, is I could come in here and I could grab this JSON directly from Azure, which has all, like, if I were to manually create this in Azure, if I had to manually change something, I need to go get the value back out. I could go take this information here, copy this. I could go back over to my stack and I could grab values out and manipulate this to be able to get it to look like what I had in Azure. So when I did an import and when I went and ran a preview, I shouldn't have a diff between my two changes. So it's kind of a way to munge that a little bit. But there's just kind of few options available for extreme like edge cases, like if you ran into like weird state problems. So try to think if there's anything else that's like super pressing. I think I covered a lot of like the really major things in here. There are, like I mentioned before, there are some converters that are available. There's a lot of things available through the CLI, like new, config, stack, preview, destroy. You can do exports. You can do all sorts of other things with it. Lots of API references in here, SDKs, right, that you can pull in. There's a whole bunch of different things as well in here that are available. Definitely can't cover everything in an hour, but I tried to cover a lot of like the really high important things. But yeah, like if you were just to get started, they have some stuff in here around what to do. You know, if you're using Mac, how to get started, specifically how to get started with the language. You know, they kind of walk you through getting started guides in here to get all that stuff kind of going if you wanted to play with it as well. So I don't have anything else unless anybody has any like pressing questions I can answer quickly, but I think we're right at time. So
anybody have any questions for Brian or Brian, excuse me?
So are you using Pulumi does it have its own secrets manager, or are you using it with Azure Key Vault or AWS SSM?
Yeah, so depends on the scenario. So when it's secrets specific to like configuring the stack, what we end up doing, and I'll actually show this real quick. Let me just do another quick screen share. So in this example here, and I'll just close this. What I usually end up doing is when I'm configuring my actual application itself, what I usually end up doing is I shove secrets directly into Key Vault. And in this example here, because I'm using Azure, let's go into program.cs. I'm actually in a deployed environment as I'm registering Key Vault as a configuration source on my application. So my secrets are loaded at runtime when the application starts on this example. Now, for secrets that are specific to configuring my infrastructure, I just let Pulumi manage those secrets for me. And then as far as like provisioning those secrets, like if I had a secret that was pulled from like for GitHub, for instance, I would just use GitHub secrets in here. And so like GitHub can manage secrets, you can reference those secrets. So like some of that secrets management is entirely environment driven, but for like infrastructure, I would typically just use combination of like GitHub secrets and that. And then for app secrets, I would use Key Vault to register a runtime configuration source.
So when you configure it as a runtime configuration, is that in addition to app config? So like for non-secret URLs or whatever, you can use app config, or are you using Key Vault for everything?
So we use a combination. So for instance, down here, notice I've got like website service storage and container start limits and environment. Like these are not sensitive values, right? So I'm just shoving these directly into my web app settings. For things that are sensitive, like a good example of that might be a database secret. So for instance, like my connection string to my database, I would just shove that in the key vault, and then that would get loaded at runtime to connect to that database. So it's like a hybrid. So like non-sensitive like stuff I would shove in here, sensitive stuff I would put in Key Vault, and then other things that I don't really care about, like maybe I had something specific, right? A good example could be like, oh, it's a identity provider URL or something. I would probably just shove it in app settings or something like that on a per environment basis. We use a little bit of a hybrid of all three, depending upon the use case. Any other questions? All
I'll go ahead and
right.
stop the recording if anybody want to ask any last minute questions, or we can go ahead and do the drawing.